integral tests for convergence and divergence. And suppose you are given a equation and you are given a series summation as n tends from 1 to infinity of 1 over n plus 3 into bracket squared. Is this series converging or diverging? Using the integral test, the series will diverge or converge if the integral from 1 to infinity of fx, the function dx, if this integral will give us a finite number or a known number, a finite number, for example 1, 2, 10, or let us call it n, then it is converging. It converges. The series converges. But again, if the series gives us an infinite or an infinite number, that is infinite, then it diverges. And to ascertain whether in this case, in our example, or in a question, you have to confirm whether integral test is applicable. Then the three conditions or axioms must hold. The first axiom is that the function has to be positive, it has to be positive, it has to be continuous, and again it has to be decreasing. That is when x is greater than or equal to 1 and between interval 1 to infinity. So is our function positive? Okay, this is our series. Let's say our an, then we find the corresponding function, that is function fn, which is we derive it from this point, that's 1 over x plus 3 squared. Is this function positive? Yes, it is positive, because if we have 1 plus this one is 4, positive number divided by positive is positive. But at -3, when x equals to -3, it is not positive. So, but remember, we are considering between interval 1 and infinity. This one, 1 and infinity. So at 1 it is positive to infinity. So this one, it is positive. Is it continuous? Of course, it is not continuous. Let's say this is our interval. This is -3, this is 1, this is to infinity. Then our function is not continuous at this point at -3, but from here it is continuous to infinity, heading to infinity. So meaning, because it is continuous between negative, our function is continuous between -3 and infinity, it is also continuous between interval 1 and infinity. So it is continuous. Then is our function decreasing? In order to ascertain whether our function is decreasing, we will find what we call, we find the first derivative of the function. That's f derivative, denoted as f, some apostrophe there, some kind of denotation there, up there. Then will give us, that is x dx. Then it has to be, our first derivative has to be a negative in order for us to say that it is decreasing, the function is decreasing. So 1, using u substitution, we will have u over u over it will be 1 over u times du. Then we do the u substitution. That one we'll go further and find u. Let's say our u equals to this one, x plus 3. Then we'll have this one will be, because this one should be u squared du. In order to find that derivative, is 1 over u squared. So which is u negative 2 when you solve this one, then times du, this one du, this du here, which is equal to u negative 2, which equals to times du equals to 1 over 1 over x plus 3. Then this one will turn into, will get us to negative 1 over u, then which is negative 1 over x plus 3. That's the derivative. Yes, it is decreasing because if we divide our function, a negative by positive is given as a negative, so it is decreasing. Then we are now free to invoke or put into use the integral test, and if we find a finite number, then it will be decreasing. Then we find the integral 1 to b over negative 1 over x plus 3, which is from 1 to b, which will be limit as b, we have to make some feasibility, as b approaches infinity is negative 1 over b plus 3, then which will give us minus, then again we'll be having negative 1, this one, and this is 3 when we take our b is 0. Then we shall be having this one will give us 0, this one will give us 0, and when we have our b, this one will give us 0. Negative 1 over b is 0. Then this one minus, of course we do some substitution. This one will be added here and plus 1. Then we'll be having, that is plus, on this side this one will go to 0 because negative 1 over b is 0, or negative 1 over b plus 3 is still 0. Then this one, negative minus negative, will turn into a positive. Then we'll have 1 over 4. Okay, 1 over 4 is finite. Our function, our integral between 1 b and infinity, it is our function between b and infinity is finite, so it is converging. Again, we'll say our function also is also converging. Tentatively, our series, because we found a finite number, converges because 1 over 4 is a finite number. That is when we do integration. Yeah. Just a clarity on finding that this derivative. On finding the derivative of 1 over this function, we are going to have, that is x, the function transforms to x plus 3 negative 2 because of that numerator. Okay, then 1 disappears, which will give us negative 2 and x plus 3 then raised to power negative 3, this one minus 1, then negative 3 multiplied by 1. The derivative of this one is 0. The derivative of x is 1, then multiplied by 1, which is negative 2, then x plus 3, then raised to power negative 3. So, of course, the first derivative is a negative, as we can see. The first derivative is a negative of this function. So it is decreasing, the function is decreasing. And of course, because we found that a finite number, 1 over 4, then the series is converging.